Alright, so today we're going to take our distillate, which we got from our isolation of eugenol and acetyleugenol from cloves, and we're actually going to separate eugenol and acetyleugenol. And to do that, we're going to use a separatory funnel. Separatory funnel, as said, helps us to separate things out, particularly organic compounds from polar aqueous compounds. Alright, so the first step we're going to do, we'll pour our distillate into the separatory funnel. Now, a couple things. You want to make sure this is closed, right? Otherwise your stuff will just drain straight out. We also want to add in some methyl terbial ether. This is an organic solvent. An organic solvent, right? Organic things are soluble in it. So it has carbon. Our two compounds we want to have carbon. So I have methyl terbial ether here. I'm going to add that to our mixture. And what you should see, cap it, is you should see layers. You should see two layers. I could probably add some more organic solvent here actually if I wanted to. So I should see two layers. But what I need to do is my eugenol and acetyleugenol are in the water layer, right? I need to mix these up enough so the eugenol and acetyleugenol go into the organic layer. So I'm going to take this, cap my hand over the top, grip it like so, and I'm going to shake it. I'm going to vent it, preferably away from your lab partner. You shake it and vent, you can hear it, shake it and vent. Put it back down, take the top off, otherwise the top will go flying off. Take your top off. Right? Now, you gotta keep track of what layer is what. So the way I like to do that is, beakers hold aqueous things, Erlenmeyers hold organic things. So if you remember, think about our layers, the top layer, remember, was an organic layer. And the bottom layer should be water. So I'm actually going to add a little more organic just so we can see that line even better. There we go. So now you can actually see that differentiation. So now what we need to do, we need to separate these out. Aqueous things go in beakers. So that's coming out first. We want to wash the line. And we want to make sure we don't get any aqueous things in the organic things in the aqueous layer. This highlights an important concept of like dissolves like, which we'll really be hitting on here. Right, so right now we're just taking the eugenol and acetyleugenol out of the water. But we also want to separate those two from each other, and that's going to involve some acid-base chemistry. So now we're getting close. We can close it up. Now we have a aqueous or organic left in there, and we put those things in Erlenmeyers. So we'll open up the drain again. Now in our Erlenmeyer, right, in this organic solvent should be the eugenol and the acetyleugenol. But now to double check or triple check to make sure we get all the acetyleugenol and eugenol out from our extraction, we want to put this aqueous back in there and add again more organic solvent to extract out even more. So that's the first step. I'm not going to show that again. The next thing you're going to do is you take your combined organics, right? So this would have two more washes, two more sets of ether from our first set. Pour those back into the sub funnel. Now with this, we're going to use some acid-base chemistry. We're going to add 10% NaOH, which is a base. The base is going to interact and react with eugenol. It's going to take the hydrogen off eugenol and give eugenol a negative charge. When eugenol has a negative charge, it's going to be soluble in water. So again, we'll have two layers, but now our eugenol should be in our aqueous layer, and our acetyleugenol should just be in the organic because it reacted in an acid-base sense. But again, we want to shake it up to make sure we get that. Cap it, shake, 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 vent, shake, 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 vent, shake, 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 vent. All right, so what that should have done was deprotonate the eugenol, put that with a negative charge, put that in the aqueous layer, and left the acetyleugenol in the organic layer. So So again, we're going to separate these things out, put the aqueous portion into a beaker. We had actually done that a couple times. We'd actually washed the organic with sodium hydroxide solution a couple more times, but just for sake, we're not going to do that here. So now this aqueous layer should have the eugenol in it with a negative charge, and the organic layer should only have the acetyleugenol. Now we're going to leave that in there for a second. We're actually going to add saturated sodium chloride solution. We want to make sure we have no water in there. So a really polar sodium chloride solution will make sure we do not have any water in our organic layer left. So we pour that in. Right? Again, we shake it all up. We get 2 layers, but this layer is this wash with sodium chloride is actually helping us get rid of any water that might be stuck in the organic layer. So pour that back in here. So what you'll find is a lot of these washes have to do with making sure there's no water left in the organic layer, because we really want to get rid of water. We want dry compounds. So we've washed with sodium chloride, and now we're going to use calcium chloride, which is a drying agent, to soak up even that last little bit of water. So we take our organic and we add it into our solution of saturated calcium chloride, or of calcium chloride. And we let this sit and let it dry. So there's little calcium chloride soaks up water. You can kind of see it fizzing there a little bit. We let that sit and dry, and then we eventually will take that, transfer it to a round bottom, and we'll use the rotovap. But now we want to make sure we have our acetyleugenol, right? Or excuse me, at this point we have a eugenol in here. Acetyleugenol is there. Our eugenol is still in here, so now what we need to do is we need to put that proton back on. So to do that, we'd go to the hood and use hydrochloric acid. Right? This is now a negatively charged conjugate base. If we add acid, it would be protonated and no longer be charged, and then would be soluble in organic compounds, organic solvents. Once we get this to a certain pH of 1, which we'd use pH paper for, to test where the pH is at, we take this, add it back to our set funnel, and essentially repeat the process which we just did, right, of extracting out the now protonated eugenol from the aqueous layer. So it wouldn't be soluble in the water anymore, and now it'd be soluble in our organic solvent.